What happens when the sun goes silent for 1 week? At first, the question sounds almost comforting. No solar flares, no bursts of radiation, no space weather alerts. Astronomers report unusually calm observations. Space agencies notice fewer disturbances. Satellite operators enjoy a rare period of stability. The sun appears unchanged in the sky. Still bright, still warm, still rising every morning. Most people imagine that a quieter sun would simply mean fewer problems. Perhaps technology becomes more reliable. Perhaps communication systems experience fewer disruptions. Perhaps nothing important changes at all. After all, the sun has always been there. It continues shining. It continues warming Earth. It continues illuminating the sky. If it suddenly became quiet for only 1 week, how much difference could it really make? Perhaps very little. Perhaps humanity barely notices. Perhaps life continues normally. But that's not even the most dangerous part. The real danger is that the sun is not merely a giant source of light, it is an active star. A constantly operating engine of energy, particles, and magnetic activity. Every second, invisible streams flow outward from its surface. Every second, Earth exists within that flow. And if that activity suddenly stopped, the consequences would reach far beyond the sun itself. To understand why, we first need to understand what the sun is actually doing right now. Deep within the sun, nuclear fusion continuously releases energy. That energy moves outward through layers of plasma. Magnetic fields twist across its surface. Charged particles stream into space as the solar wind. Earth travels through this environment every day. Most people never notice it, yet spacecraft monitor it constantly. The solar wind shapes the boundaries of the heliosphere. Auroras shimmer near Earth's poles. Satellites navigate through changing radiation conditions. Astronomers track solar activity across the entire star. The sun appears calm from Earth, but beneath that appearance, immense activity never truly stops. Now imagine that activity suddenly ends. Not the sunlight, not the heat, only the activity. The solar wind ceases. The magnetic disturbances cease. The streams of charged particles vanish. For the first few hours, almost nobody notices. People wake up, traffic moves, aircraft depart, ships cross oceans, cities continue operating. The world appears completely normal. Yet high above Earth, instruments begin detecting something strange. Spacecraft monitoring solar particles record unusual readings. The numbers continue falling. Then they fall further. Eventually, they reach levels never previously observed. The flow has stopped. The sun has become silent. The first effects appear in space. The heliosphere begins changing. This vast protective bubble surrounding our solar system exists partly because of the solar wind. Without that outward pressure, its boundaries begin responding. Cosmic radiation that was previously deflected encounters less resistance. Scientific observatories notice unusual particle behavior. Research satellites detect shifts in the near-space environment. Mission control centers around the world begin analyzing data. Astronomers compare observations. Engineers verify instruments. The anomaly refuses to disappear. Then Earth's magnetic environment begins responding. The magnetosphere constantly interacts with the solar wind. Normally, the two systems push against one another. Now one side of the interaction has vanished. The shape of Earth's magnetic shield begins changing. Auroras fade. Polar skies that once glowed with shifting curtains of light become unusually dark. Photographers waiting beneath northern skies find nothing. The familiar display is gone. The silence is spreading. Then communication systems begin noticing subtle consequences. Space weather forecasting becomes uncertain. Models built around constant solar activity encounter conditions never previously measured. Satellite operators review contingency plans. Scientific agencies coordinate observations. Researchers search historical records. No modern civilization has ever observed a sun behaving quite like this. The damage phase begins, not through destruction, through uncertainty. Spacecraft operating beyond Earth's magnetic protection experience changing radiation conditions. Long-duration missions require additional monitoring. Astronauts aboard orbital stations receive updated safety assessments. Deep space probes collect unexpected data. The environment surrounding Earth becomes harder to predict. The atmosphere begins responding as well. The upper atmosphere normally absorbs energy from solar activity. Without that activity, conditions begin shifting. Small changes emerge first. Then larger ones follow. Satellite drag calculations become less reliable. Orbital predictions require adjustment. Tracking systems update models continuously. The systems supporting space operations begin adapting. Yet even this is not the most significant consequence, because modern civilization depends heavily on prediction, and prediction depends heavily on understanding stable systems. When one of the most important systems in the solar system behaves unexpectedly, uncertainty spreads rapidly. Then the escalation begins. Scientific forecasts become less reliable. Less reliable forecasts complicate satellite operations. More complicated operations increase operational costs. Higher costs place pressure on research programs. Research delays slow data collection. Reduced data weakens future forecasting. Space agencies face growing uncertainty. Communication networks dependent upon satellite infrastructure become harder to manage. Navigation systems require additional corrections. Aviation planners increase monitoring. Maritime operators increase monitoring. Power grid operators increase monitoring. Governments request additional scientific analysis. The anomaly continues. Day after day, the sun remains silent. Then the broader consequences begin spreading. The effects do not remain confined to observatories. Financial markets respond to uncertainty. Insurance models incorporate new risks. Technology companies reassess infrastructure vulnerabilities. Military organizations review space-dependent systems. Emergency management agencies evaluate contingency plans. International cooperation increases. Scientists share observations across continents. The event becomes global not because it causes immediate destruction, but because it affects systems that connect the entire world. Meanwhile, the solar system itself continues responding. Cosmic rays penetrate regions they normally reach less efficiently. Particle detectors record unusual measurements. Observatories collect valuable data. Researchers gain unprecedented insight into the protective role normally played by solar activity. The silence becomes a scientific event unlike any previously observed. Days pass, then more days pass. The sun continues shining. Sunrises remain beautiful. Sunsets remain beautiful. The oceans continue moving. The atmosphere continues circulating. The planet remains alive. Yet beneath ordinary life, countless instruments continue recording change. The absence itself becomes the story. Then the week approaches its end. Scientists remain uncertain. Some expect activity to resume. Others prepare for a longer anomaly. Space agencies maintain heightened observation. The world waits. Then activity returns. Solar particles appear once again. Measurements begin rising. The solar wind resumes. Earth's magnetic environment responds. Auroras gradually return. The familiar interaction between star and planet reawakens. The immediate crisis ends, but the lesson remains. Years pass. Research papers are published. New monitoring systems are developed. Space weather forecasting improves. Satellite design standards evolve. International scientific cooperation expands. Humanity learns from the event, because adaptation is one of humanity's defining strengths. Yet adaptation does not erase what was revealed. The week exposed something deeper, something easy to overlook. The sun is not merely a light in the sky. It is an active participant in Earth's environment. Its influence extends far beyond daylight, far beyond warmth, far beyond what most people ever see. And perhaps that is the most unsettling realization of all. The systems supporting civilization are often invisible, not because they are distant, but because they are constant. The magnetic field surrounding Earth, the atmosphere surrounding Earth, the streams of particles flowing from the sun. Most people never think about them, because they operate continuously, because they rarely demand attention, and because they rarely demand attention, they begin to feel permanent. Yet permanence is often an illusion. The stability of civilization depends upon countless processes unfolding quietly beyond human awareness. Some occur deep beneath Earth's crust. Some occur high above the atmosphere. And some begin 93 million miles away on the surface of a star that never asks for attention, yet influences every satellite, every communication system, every scientific observation, and every moment of ordinary life. If you enjoyed this journey into the hidden systems that shape our world, please like, share, and subscribe to the channel. What would you do if the sun went silent today? Let us know in the comments. Thank you for watching. Stay curious.